Hey there, science fans! Today, we're diving into the incredible world of homeostasis. Imagine a tightrope walker carefully balancing, constantly adjusting to stay upright. That's a lot like homeostasis, the process by which our bodies maintain a stable internal environment. Just like that tightrope walker needs balance to stay on the rope, our bodies need balance to function correctly. Whether it's temperature, blood sugar levels, or water content, everything needs to be just right. This balancing act is maintained by intricate feedback systems. These systems are like your body's internal control panel, constantly monitoring and adjusting different variables to keep you in tip-top shape. It's a bit like a thermostat in your house, kicking in the heat when it gets too cold and the AC when it's too warm. So, buckle up as we explore the fascinating world of feedback systems and learn how they keep us alive and kicking. Get ready for an exciting journey into the inner workings of your amazing body. Now let's meet the key players in this intricate balancing act: receptors, control centers, and effectors. Think of them as a relay team, each with a specific role to play. First up, we have the receptors, our body's sensors. They're like tiny antennas constantly picking up signals from the environment and within the body. These signals could be anything from changes in temperature to the levels of different substances in your blood. Once the receptors detect a change, they pass the baton to the control center, often located in the brain. This is the command center, analyzing the information received and deciding on the appropriate course of action. Finally, we have the effectors, the muscles and glands that carry out the control center's orders. They're the ones who actually make the changes needed to restore balance. For example, if your body temperature drops, your muscles might shiver to generate heat. Now let's talk about the most common type of feedback system: negative feedback. Don't let the name fool you, it's not a bad thing. In fact, it's crucial for maintaining a stable internal environment. Negative feedback loops work by counteracting any changes from the set point, like a tug of war that keeps things balanced. If a variable rises above the set point, the system acts to lower it, and vice versa. A great example of this is blood glucose regulation. After you eat, your blood sugar levels rise. This rise is detected by receptors in your pancreas, which act as the control center in this case. The pancreas then releases insulin, a hormone that acts as an effector, helping your cells absorb glucose from the blood and lowering blood sugar levels back to the set point. Similarly, if your blood sugar drops too low, the pancreas releases another hormone called glucagon, which instructs the liver to release stored glucose into the blood, bringing the levels back up. This constant back and forth ensures your blood sugar stays within a healthy range, preventing drastic fluctuations that could be harmful to your body. Section 4. Positive feedback, a cascade of events. Unlike negative feedback, which aims to maintain stability, positive feedback loops amplify a change, taking it further away from the set point. This might sound counterintuitive, but it's essential for certain processes. Think of it like a snowball rolling down a hill, getting bigger and bigger as it goes. This snowball effect is what happens in positive feedback loops. One of the best examples of this is blood clotting. When you get a cut, your body kicks into gear to stop the bleeding. Platelets, small cell fragments in your blood, start to stick to the injured site, forming a plug. As more platelets gather, they release chemicals that attract even more platelets, amplifying the clotting process. This positive feedback loop continues until a solid clot forms, effectively sealing the wound and preventing further blood loss. Once the bleeding stops, the loop is broken and the body returns to its normal state. Section 5, comparing the two negative versus positive feedback. So we've learned about two types of feedback systems, negative and positive, but how do they stack up against each other? Well, the main difference lies in their goals. Negative feedback aims to maintain stability, like a thermostat keeping your house at a constant temperature. It counteracts changes, bringing the system back to the set point. Positive feedback, on the other hand, amplifies change, like the snowball effect we talked about. It takes the system further away from the set point, often resulting in a rapid and significant change. While they have different approaches, both types of feedback are crucial for our survival. Negative feedback ensures our internal environment stays within a healthy range, while positive feedback allows for rapid responses to specific situations. Section 6, Conclusion, Feedback Systems, essential for life. As we've seen, Feedback systems are the unsung heroes of our bodies, working tirelessly behind the scenes to keep us alive and functioning. From regulating temperature to controlling blood sugar levels and even healing wounds, these intricate systems are essential for maintaining homeostasis. Next time you think about how amazing your body is, remember the incredible work of your feedback systems. They're a testament to the power of balance and the elegance of biological design. So, stay curious, keep exploring, and never stop learning about